First of all, thank you so much for being a part of this webinar where we are going to deep dive into the world of hybrid cloud and explore all the different services for AWS. Before I talk about what the actual core details are, I would like to just go through the core agenda for this webinar. We're going to start off by a bit of a brief introduction about Royal Cyber and about yours truly, me. And from there, we're going to then talk about all the different benefits about what hybrid cloud is, what in general, and what are the different benefits of it. And then we're going to talk about all the different services that AWS basically provides. What is the impact of those services? What do those services actually do? And then after that, we're going to talk about a few different architectures that are commonly used within the hybrid cloud space, like hub and spoke, cloud bursting, edge computing, distributed, etc. And after that, we're going to talk about a case study that we recently did with one of our customer, how where they faced a lot of different challenges, and how hybrid cloud services, or should I say the hybrid cloud strategy, helped them solve those problems, and then be and truly migrate and modernize from complete on-prem to a more hybrid solution. After that, we're going to just move into Q&A and then simply conclude the webinar. So a bit about Royal Cyber. So, Royal Cyber is a digital transformation and IT consulting company which specializes in services, solutions, and software. We've been working in the market for more than 20 years. We have more than 2,000 plus employees, and we have 10 plus different offshore offices situated around the globe. And we've worked with Fortune 500 different companies. And as you can see in the map, we tend to provide 24 by 7 services because of our employee expansion in all around the world in different parts of the globe. So a bit about me. So my name is Sumat, and I am basically the global cloud practice head within Royal Cyber, where I overlook all of the cloud solution operations and work very closely with different prospects and resources, where I understand their core challenges and then come up with the right solution with a team of different experts from Google Cloud, AWS, Azure, Oracle, and OpenShift from IBM as well. If you guys would like to reach me out, you can. My email address is present over there, which is suman.baloch@royalcyber.com, or you can also reach me out over to LinkedIn by just simply searching for Sumar Baloch, or probably like if you want to type out the whole URL, which is /in/Sumar Baloch. So I think that's all for the introductions. Now let's just directly talk about hybrid cloud. So basically, if I would like to sum up what hybrid cloud actually is, so hybrid cloud is actually a combination of different cloud environments working together. So when I say different cloud environments, I talk about, let's say, public clouds, private clouds, traditional infrastructures, all of them when work together combinedly in a single phased approach. That's what hybrid cloud is. The need for hybrid cloud arose really from the legacy debt that a lot of different organizations actually go through. So for example, if there's a company that's been working in the market for more than 20-30 years, they have transitioned from manual to automation, but but that automation came with a cost where they had to rely very heavily on-premises infrastructures, on-premises resources that they've deployed and they've built on. Now the problem is that it's not easy for a lot of companies to just move to the cloud. It doesn't work like that, because there's a lot of dependency in that legacy code, in that legacy infrastructure that's already there. That's where partners like us come in. We understand the legacy environment that they're currently working on, the challenges of the legacy environment, and then we come up with a hybrid cloud solution where we try to migrate some workloads to the cloud, like either to a public cloud or to a private cloud, and then we try to work around with some workloads that are already running on prem, and slowly and gradually we do the transition from point A to point B, so that eventually with a particular span of time they become completely on the cloud itself. That's the whole game plan. That's the whole mindset of the hybrid cloud approach. Now, one would ask is like, okay, I get it that hybrid cloud is this is this armada where I can run different environments within the same infrastructure. But what are the benefits of going hybrid? So basically, if you talk about benefits, so like number one is scalability. You tend to be really scalable when you are working on the hybrid approach, because since you're utilizing some workloads on the cloud itself, the best part about working on the cloud is that you can easily set up workloads to be horizontally scaled up or scaled down depending on the traffic needs that your infrastructure is currently facing. The second advantage is definitely cost effectiveness. Like for example, in an on-premises infrastructure, in order for you to go to make it to be scalable, to be horizontally scalable, you would always have to set up another rack or buy another machine, buy another rack. So it's always there's always a very heavy cost that's involved for you to actually maintain that infrastructure. So because you don't just have to maintain it, but you have to buy the infrastructure as well. So that really ramps up the cost. But if you go with the more hybrid approach, now you don't have to actually buy the equipment. The equipment will actually be managed by some of the any of the vendor. In this case, we're talking about AWS, and you just have to focus more on managing that infrastructure. So that really helps on cost effectiveness. The next part is definitely flexibility. So basically, when you are transitioning over to the cloud, it gives you a lot of space to do a lot of different experimentations to modernize. Actually, that gives you a lot of flexibility, because once you do modernization over to the cloud itself, you tend to add new services that get launched as the time grows, and you also tend to do a lot of different experiments, run different POCs, and try to see what fits with your business use cases. That's where the flexibility really comes in. Next part is security. So basically, when you choose a vendor, in this case AWS, you tend to inherit the security posture as well that those CSPMs actually offer you. When we talk about security, we tend to focus more on, let's say, SOC 2 compliance, PCI compliance, depending on the type of vertical that you're actually focusing on. The next part is reduced latency. So basically, uh, if you're already if you're completely dependent on prem, latency is one of the core challenges that a lot of different companies have to adhere to, because everyone wants their business to grow, everyone wants to go global. But as you're going to grow, as you're going to go global, it's going to create all other different challenges for you, latency being one of the core challenges. Because for example, let's say if your data center is actually situated in US Eastern 1, and somebody is trying to access your website or your application from Singapore, definitely there's going to be a lot of latency over there, because obviously because of the distance. That's where you tend to use these different services, like Outpost or transit gateways that AWS provides, which gives you that the credibility to work on reduced latencies. Next is definitely it's easier to migrate. So for example, let's say if you migrate one workload, two workloads, three workloads over to the cloud, eventually and gradually, you tend to it's a lot easier for you to migrate, basically, from point A to point B, because it gives you the idea that how do I do the migration, because it gives you the good amount of time to do plan it out, how actually you're going to do migrate all of those different workloads one by one. Compliances, disaster recovery, agility, again, all of these different aspects, they come with the cloud vendor, and also the also your infrastructure that goes along with it, right? Now, the next thing that I wanted to talk about is all of the different AWS hybrid cloud services that basically AWS provides. So we're going to discuss a bit more into details in what these different AWS services are, what do they do, and what is their role, and what different use cases do they actually adhere to. Right. So starting off, we have AWS Outposts. So as I mentioned earlier a bit, AWS Outpost is think of it as a mobility AWS infrastructure. It's a mobile AWS infrastructure. So basically, AWS Outpost is like a rack which provides you compute, storage, and all the different services that you would think of, connecting you from one data center on site to the AWS cloud itself. The best part about the Outpost is that it's a mini cloud that can actually run on site within which is nearest to your location, and it's actually connecting to the main AWS infrastructure as well. So what that does is that it gives you that leverage of, like I said, since you're already on prem, you're just too much dependent on all of these different equipment that you need to buy. So you don't need to you just need to like simply just get the AWS equipment itself and just rack it up there in your on premises infrastructure, and just you plug that in with your on-prem data centers. The best part about doing all of this is that it gives you two basic advantages. Number one is that you're going to get hooked to the AWS infrastructure, right, by not completely relying on the AWS infrastructure. So it's like sort of like a miniature version of the major infrastructure of the AWS. The second part is that AWS infrastructure has the ability to connect to a global AWS services that can be provided to you. So basically, using Outpost, you tend to work around with all of these different criterias of different services like compute and storage, and just utilize that with your particular use case, and just plug it in, and that way it gives you that opportunity to not only understand the AWS services, but also able to plan it out how you're going to do the migration, since you're already using AWS services on premises with the Outpost. The second service that I want to really talk about is Transit Gateway. Now, this is a very interesting service from AWS. What Transit Gateway actually does is, think of Transit Gateway as a VPCs but on steroids. So basically, Transit Gateways are like, they provide you a network infrastructure for your on-premises cloud itself. You can connect the different Amazon VPCs, sorry, AWS VPCs with the Transit Gateway, and they can easily get hooked up to your on-premises network itself. Now, when we talk about virtualization within the cloud itself, the cloud has subnets and subsets that are called virtual private clouds, which stands for VPCs. Now, what those VPCs do is they isolate your workloads within the infrastructure, and through that isolation, you tend to run different workloads within that particular space, and that really creates a lot of traction for your infrastructure. So, for example, let's say there's a particular service that you're running on AWS there, where you do not want anyone from the outside world to connect to that. So it's something that's running on an intranet internally. You don't want anyone else to connect to that, right? So you tend to put that service within a VPC, and then you put a firewall on top of the VPC, which blocks out any of the external connections, or anyone who tries to connect to externally through that infrastructure. So it really blocks out all of that. So VPCs really help you do that. Now think of that particular feature coming to your on-premises cloud itself. So what Transit Gateway helps you do is that it connects with your local and on-premises environment, and then utilizes the AWS's VPCs on top of the network infrastructure that you already have deployed. So that's what Transit Gateways help you do. It's another service which is very commonly used within hybrid cloud space, and that's what Transit Gateways are majorly used for. The next service that I want to talk about are storage gateways. So, as the name implies, storage gateways are basically mechanisms of storing your information in different variations. So, for example, there are three different types of storage gateways that AWS basically provides you. There's a file gateway, which basically provides an interface to store and retrieve files from and to Amazon S3 buckets. Then there are volume gateways, which basically provides you block storage volumes over backed up Amazon S3 or EBS's volumes. And then finally, there's a tape gateway, which basically provides a virtual tape library for backup and archiving backed up to Amazon S3 or Glacier. So basically, uh, what we do is that, in terms of storage, storing in different files, again, uh, when you're completely utilizing on premises, you tend to store a lot of these different files in either, different volumes, or probably like you have different buckets that are already set up within the infrastructure, where you tend to store your files, your data, right, into all of these different drives, right? What storage gateway helps you do is that by utilizing this service, you tend to connect to S3 buckets, which are the primary storage service from AWS itself. And then you basically utilize the type of storage that you want to target. So for example, if you're simply storing files like images, or backup files, or anything on that front, so basically you tend to use file gateways. The second is like a volume gateway. So for example, if you're trying to store EBSS volumes, like let's say application data, or storage data, then you tend to use volume gateway. The third is the tape gateway. Now tape gateway is more on the front of, let's say, virtual tape libraries that you're trying to archiving and everything. So basically, if you're trying to archive things, if you have an archive based case study, that's where you will be using tape gateway. In the hybrid cloud space, what storage gateways, the best benefit about using storage gateways is that you don't have to use your local drives that you have been using within on premises, and you don't have to maintain those drives as well. Because see, the problem is that it's easier for you to deploy these drives, but it gets really hard for you to actually maintain those drives, because you don't have the visibility, you don't have the locality to actually understand who actually owns the drives, and then what data is actually residing within those drives itself. If you tend to try it, if you tend to tend to see that, okay, I want to expand the information that is present in the drive itself, or I want to understand that that's a whole other activity on its own, that takes a lot of time for you to get that information out. But if you are utilizing a storage gateway from AWS, it's just 2 or 3 clicks to just go to the storage gateway page within AWS, within the AWS console, and then just simply use either a CloudWatch events or a CloudWatch storage structure, and just see that what are the files that are actually stored over there, and what is the different use case for them. All right. So the next service that I want to talk about is Cloud Formation. Now, a lot of you who are already AWS enthusiasts, or should I say, someone who's already using AWS, they might have their eyebrows raised of like, okay, Cloud Formation is not a hybrid service, because Cloud Formation is simply a template that deploys the infrastructure, right? uh, but to be honest, that's just, I would say, one part of what the Cloud Formation templates can actually do. The Cloud Formation and templates can actually expand into on premises as well. So for example, let's say you're using AWS Outpost, right? For example, now AWS Outposts is basically a combination of different AWS services that are already present within on premises. Then what you do is you create a cloud formation template, and then you run that template within those outposts, and it will automatically create an infrastructure for you, virtualize the infrastructure for you on your own landing zone. That's the best part about cloud formation. That's why I added cloud formation within the hybrid cloud services. Reason being is that it expands into hybrid cloud domain, because you're able to run cloud formation templates on premises as well. So a lot of people had this have this idea that maybe cloud formation templates can only run on the cloud, because CFTs are very specific to AWS, and a lot of people might have actually used CFTs when they were fiddling, or probably like professionally using AWS. But you can also expand the CFTs within the hybrid structure as well. So that's why I added it into the hybrid cloud space. So the next service that I wanted to talk about is AWS Direct Connect. Now, Direct Connect is one of the core fundamental service that basically helps you connect from on premises to the AWS cloud itself. I cannot emphasize enough all the different use cases that you can actually come across when you're using Direct Connect. Now, the best benefit about using Direct Connect is that you tend to connect with you tend to connect your services from on premises to the cloud. That those use cases can expand to, let's say, transitioning data from point A to point B. Let's say from on premises to the cloud, you're trying to transition or transfer that data. Direct Connect is a great way to do that. Or you're trying to connect some on-premises services to the cloud itself. That's where direct connect really creates that environment for you, or that opportunity for you, where you can just simply talk to an AWS infrastructure from your on-premises environment itself. Now, Direct Connect has different layers on top of it. So, for example, there's a Direct Connect gateway, there's a Direct Connect link, right? So these gateways then link, and then you can utilize Route 53 as well within that equation. So what it does is that it really expands into your on-premises infrastructure and then goes way beyond to connect you with all of the AWS services, right? So compute, storage, any services that you can think of, you can actually utilize that. We've worked with different customers where we actually have used Direct Connect. So, for example, I very fondly remember this one customer who wanted to migrate their data from on premises to the AWS cloud in the S3 buckets, and the data size was, I guess, around 300 400 terabytes, if I remember it correctly. Now, there were multiple ways that you could actually do that. So, for example, transferring a data of that magnitude really requires you to either physically transfer the drives from on premises to the AWS data center. That's one way to do it. I've seen companies do it. People do it. I mean, that's something they're comfortable with. Or sometimes they tend to use the internet, to transfer that data. Again, takes a lot of time, but it is doable if anyone wants to do it. Okay. The third way is to use Direct Connect. Now, Direct Connect really increases the bandwidth, reduces your latency, and then improves the security as well, because it's more of a virtual private tunneling. It's like virtual private tunneling, but again, I'm going to use the word steroids, because you connect from one infrastructure to the other. You directly are able to talk to that infrastructure, and then you're able to transition whatever data, whatever use case that you're looking into, from point A to point B using Direct Connect. So it's a great service to work with. We've used it a lot of time in the past, and have really great results from it. So yeah, again, Direct Connect is great. And I guess, if I remember it correctly, the use case that I'm going to talk about at the end actually uses Direct Connect to that extent. So maybe I can go into more details when we reach to that stage. So, after talking about all of those different services, now I would like to talk about different hybrid cloud architectures that are commonly used within enterprises. So, if I wholly solely speak on a higher level, so number one is a hub and spoke architecture. It's a very common architecture. It's a very old architecture, I would say. No, and a lot of different companies actually use that, who have been very traditional, very on-prem infrastructure way of thinking. So yeah, hub and spoke is something that a lot of companies actually use, especially in the telco business. Actually, a lot of telcos actually are, as of now, still dependent on the hub and spoke architecture. The second is cloud bursting. Cloud bursting is a great way to for you to really augment your data latencies, whenever you're peaking. You have a peak overload or peak timings. Very commonly used for companies who are in the e-commerce business, especially when they have to mitigate to Black Friday sales. So cloud bursting is a great way to help cope up with the challenge in terms of traffic and latency. So cloud bursting is a great way to do that. Edge computing architecture is again a great is one very commonly used again with telcos, because edge computing actually does is that it gives you that capability to to basically process a lot of data for remote locations. So, for example, if I talk about telcos now, in telcos have a lot of they have a lot of remote locations situated in different parts of the of a particular landscape. uh, as an example, we can think of the antennas, right? So it's very hard to fetch the data that is being produced from all of those different sites. That's where edge computing architectures comes into play, where you put edge nodes within those sites that help you reduce the latency, extract the information, so extract the data that is getting produced on those particular sites, and then send it back to the central location. That's what edge computing actually is great for. We're going to talk more once we get to a particular dedicated slide of it. Finally, is distributed architecture, and this is one of the common architectures that is utilized within the hybrid cloud space. And even if you're not hybrid, even if you are completely purely on the cloud or multi-cloud, you tend to have gone through a distributed architecture. Now, distributed architecture is about distributing all of your workloads either from cloud to cloud, on-prem to on-prem, or probably like from one place to the other. So yeah, so distributed architecture really helps you revamp or ramp up all of your infrastructure and distribute that workload in different spans of location. So if I think now is the time to deep dive into all of these different architectures. So again, as explained earlier, the cloud bursting basically it augments your resources from on-premises data centers during peak demands. So what happens is that for example, let's say you have an on-premises data center, and then you have different cloud infrastructures that are already connected to it. The core challenge is that for example, you get a lot of excess workloads on any of the different on-premises site locations that you have, or even if your main core on premises infrastructure is currently working on basically is utilizing that. The core challenge, the problem that actually occurs is that when the peak factor hits, at that particular time and event, on premises are not equipped to handle peak events. Either you have to prerequisitely have machines built up and ready, which is again an added cost, which ramps up to you buying more infrastructure, or you tend to use a cloud bursting architecture where you connect with different cloud vendors, or in this case AWS. You connect with AWS through the cloud bursting platform. And what happens is that when the peak factor hits on the on premises area, the cloud bursting platform will actually basically expands or extends that latency to a cloud, to a nearest cloud that you've configured. uh, this way, the load actually gets distributed to different cloud locations, to different geospatial locations. That way, your service doesn't go down, and you tend to be available and online once the peak factor hits. Some of the common services that usually are adhere to cloud bursting is again storage gateways. That's a great way to do it. CloudWatch, and then System Manager. These are some of the core services on AWS that actually adhere to cloud bursting architectures. The second is edge computing architecture. So, as explained again, I briefly talked about all of these architectures in the previous slide, but I'm just going into more details in every one of them. So, if I talk about edge computing architecture, now edge computing is again very commonly used within the telco businesses, because they have a lot of different locations where those antennas are actually situated and posted. So what edge computing actually does is that you tend to create these edge nodes nearest to the location of these different sites, and then you tend to transfer the data from the site to the edge node, and then eventually to the cloud environment itself. Now, the benefit of doing that is, so for example, let's say if you're producing a lot of information, or if you're streaming a lot of information from all of these different sites, edge computing gives you that leverage and edge to basically expand your data processing capabilities from on premises to the cloud itself, and store all of the information that gets generated from those remote sites. It reduces the latency, It's very useful, very powerful when it comes to real-time data processing, and it really improves the the performance and the network congestion as well. That's where edge computing comes into a lot of it comes in really handy in terms of your particular use cases. Some of the common services for edge computing are again AWS local zones or wavelength. These are some of the common services that AWS basically provides for you to do edge computing architecture. The next service that I want to focus on is distributed. Sorry, the next architecture that I wanted to focus on is distributed architecture. Very commonly used within the industry. A lot of companies actually use and utilize distributed architecture. And again, like I said, distributed architecture does not need to be like it's not solely dependent on premises to the cloud. You can actually create a distributed architecture from cloud to cloud, or even a single cloud. So for example, if you're just using AWS, you can actually create a distributed architecture solely by using AWS alone. In this particular case, what we wanted to focus on is, so for example, let's say you have different on-premises data centers, right? And what you're trying to do is that you tend to utilize those on-premises data centers, and you want to expand that with different AWS cloud services. So what you do is that you connect those AWS on-premises data centers with global accelerators, and then from that connect that with the Route 53, and from the Route 53, it directly connects to an AWS Direct Connect from the transit gateway to the Amazon VPC, and then eventually to an EC2 instance. Now, what that distribution does is that it connect helps you connect to the cloud environment, and then utilizing all the services that you're looking for. So, for example, if you are an EC2 heavy company, you can tend to tap into EC2, you can tap into ECS, you can tap into Fargates, you can tap into storage gateways and VPCs. So basically, what you do is that through a distributed architecture, you distribute some workloads to the on-premises environment, and then you distribute some workloads over to the cloud itself. And by utilizing the global accelerator, which connects to your data center, you basically route, sorry, not map, you basically route the traffic from the on-premises to a Route 53, and the Route 53 services would actually be mapping a DNS server, resolving DNS names and the IP addresses, and then connect you through the AWS Direct Connect, which gives you access to basically your AWS infrastructure. Now you can add a transit gateway in the middle, you can add a VPC in the middle, and then you can connect to an EC2 instance, or you can simply use Direct Connect and then add a transit gateway and directly connect to an EC2 instance. You don't need to go through a VPC. By default, there is a global VPC already in place whenever you are working with any AWS infrastructure. But the best way and the best practices are that you do a transit gateway through the VPC and then eventually connect to an EC2 instance. The next architecture, and this is one of my I wouldn't say favorite, but yeah, I really like working on this architecture. This is a hub and spoke architecture. So think of hub and spoke architectures as, you know hub is your central data infrastructure, and then spokes are your different outposts or remote locations where all of those different architecture, all of your different infrastructures are actually deployed. So, for example, think of it in a way in a more of a remote site. So for example, it's very commonly used for enterprises who have a lot of remote sites. So, for example, somebody who are more focused on oil and gas, companies like Aramco or any other company who are very much focused on oil and gas facilities or services. That's where hub and spoke really works great wonders for them. Or companies who are more into mining, actually, that's where hub and spoke architectures do a great job for them. So basically, your hub, it acts as a central data site, where spokes, which are like the remote sites, they talk to the central data site. Here you tend to connect with either transit gateways, which helps you connect to the central data center from the remote sites, and then you use direct connects or VPNs to connect with all of those different spokes, which are your remote sites. And within those spokes, you tend to attach EC2 instances or any other services that you think of, which are useful for your use case, which helps you connect, helps you do your business use cases, right? So hub and spoke is like a tree structure of an architecture, where you have one central hub, and then you have multiple spokes connected to that one central hub, that one central data center. It talks to that data center, and then based on that, it basically expands into all of the different AWS services that you can think of, and really helps in connecting your remote sites to a central location. Very commonly used for companies that are more focused into oil and gas, mining, or any companies, or even telcos as well. So any companies who have a lot of remote locations, and they want one particular location that talks to a central data center. Hub and spoke architecture is the way to go for a lot of companies and enterprises. So that's about all the architectures, I guess. I don't I think we're done with the architecture part. Now the next part is that I wanted to dive deep dive into the case study. And the case study that I want to focus on is about a financial services company which has been working in the industry for more than 50 years. And to be honest, it was really fun working for this particular challenge. So basically, let me just go through what the challenge was, and how did we solve it, and what were the results of that particular solution. So the challenge was that this company was on premises, like purely on premises. They had no business with the cloud, and they were like pretty much dependent on an on-premises infrastructure and structure. They did a couple of POCs. They tried to migrate to the cloud, but then again, it's not easy for a lot of companies to do that, because you need to have a very specific skill set to actually go to the cloud, to migrate to the cloud itself. So a company of that size who is really dependent on their on premises infrastructure, it's very hard for them to migrate from on premises to the cloud. That's where this company comes into the play. So again, they had thousands of servers, and like petabytes of data. I mean, the data sets that they had were huge. I mean, honestly saying, they seriously were really jacked up in terms of the infrastructure that they had, the landscape that they had. And it was not like a single go transition. It really took its time, to be honest. It took, like, if I remember it correctly, by the time I joined the project was already running for about 7 to 8 months. And when I joined, it took around 1.5 year more. So probably like 2 year took us like 2 years for them to completely migrate over to the cloud. But the transition was very, very fruitful. So basically, the challenge is a very it's a very common it's a very common problem with companies like these, that when they're trying to scale up, when they're trying to grow their IT infrastructure, they will eventually reach a peak point where they cannot scale up more, because they would have to buy more space, equipment, deploy the equipment, hire more people, manage that infrastructure. So yeah, so it really was a big challenge for them to do risk management, and just meet their overall compute demands. I mean, it was really a big issue for them. So what we did was, so we started off with a basic assessment of their environment. It took us around 2 to 3 weeks to do the assessment, with the team that we deployed over there, and we had a very decent sized team over there. So we did an assessment, and we actually understood that, okay, so a lot of the data that is currently residing over there are actually stored in drives. And these drives are stacked up volumes within their racks, which are running within different CPUs. And and what they were doing is that they had a disaster recovery, which was also piled up into there. They had different business use cases. All of that data was just piling up into all of those different drives, racking up into those in those racks. So so the first thing that we did was, we thought like, okay, you know what, let's try to identify the data that has very less, or very, very loosely coupled with different business processes, and try to migrate that data from on premises to the cloud itself. That's where we utilize the storage gateway service to offload their data from their data storages from AWS to from sorry from the on-prem to the AWS. This really helped us free up a lot of a lot of the information, a lot of the data that was residing over there. It also gave them an opportunity to understand that a lot of the some of that data was actually useless for them, but since they did not have that visibility to actually understand where what their data actually looks like, or what is the actual structure of the data itself, so it was really very hard for them to actually come up with the right plan to offload that information. So that's where we utilize storage gateways to offload the data from their on premises to AWS. And then we were able to store that data in S3 buckets on different various locations, which was used for various applications over there. The next thing that we did was we deployed AWS Outposts within their on-premises environment, which gave us the access to AWS's compute storage services within their own data centers. So the other core problem that they were actually having is compute, because they wanted to assess a lot of different trading strategies, so a lot of real time information was getting processed over there. So what we did was, by introducing outposts within their own on premises infrastructure, we were able to utilize AWS's EC2 instances compute capabilities, and then it really allowed us to run compute intensive workloads like risk analysis, trading simulations closer to their data centers, which helped us reduce latencies and also increased the performance as well. The next thing that we did was we then used AWS Direct Connect, established a dedicated network between the on premises and the AWS environment. What that did was it helped us create this opportunity to basically go from on premises to the cloud, and then be able to transition that data from point A to point B, and then extend the infrastructure capabilities from on premises to the cloud. So it really helped us to create a very high speed connection, which was highly secure, because AWS Direct Connect is sort of like a VPN tunneling from one infrastructure to the other, and really helped us connect from the AWS environment to the on premises environment by using that. Okay, so after that, we used a couple of other services, like for example, I mean, they were not purely hybrid services, but they really ramped up and really helped us to expand the challenges, like AWS Lambda, ECS, and AWS Glue. So once we had the direct connect, once we implemented direct connect, it gave us the capability to extend into all of those different services, which were not actually hybrid, but since they were a part of the AWS infrastructure, we were able to use them. So the best thing was that by utilizing all of these different services together, it really helped us create a highly scalable, flexible, and cost-effective infrastructure that really met the demands of their business units, while while also ensuring security and integrity of the data that was preserved on the in the on-premises area and in the cloud itself. What were the results? So basically, improved scalability, reduced latency, increased security, lower costs, and overall, it really met the on par demand that they were actually looking into. So it really helped us. It really solved a lot of challenges and issues for them. So basically, because we were able to tap into AWS cloud solution part, it helped us do a great improved scalability. So the infrastructure was very scalable because it was connected to AWS. You can always have horizontally scaled up EC2 instances or any other services. As a matter of fact, it helped us reduce a lot the latency as well, because by utilizing on outposts into their on-premises environment, we were able to directly utilize the services for AWS within that within their on-premises environment, and then help us reduce the latency and improve the performance. increased the security because of dedicated networks from Direct Connect. It really ensured that the integrity of the data keeps intact from on premises to the cloud while it's being transferred. And then finally, lower cost, because obviously now when you have the AWS environment connected, you don't have to buy a new machine or start up a new machine in the environment whenever you want to do high horizontal scaling, which was the case when they were using an on-premises environment. This is what the infrastructure looked like before the hybrid modernization. So it was like a very on-premises infra where it had servers all stacked up together. Then there was a storage gateway, the direct connect, and then outpost that were connected and talking to each other. And eventually when we did the modernization, we basically we put direct connect within the on-premises environment, and then the outpost gave us the capability to do compute storage services and other services within AWS as well. So this was all about the hybrid cloud modernization and the techniques and the approaches that we tend to do within that environment. So anyone who's actually a part of the webinar right now, or even if they want to extend it over to, so we're open to provide you 2 weeks of free assessment where we're going to help you do discovery, analyze, plan out, and then point to execution as well. So basically, if you're a customer, or you are someone who's actually dealing with a technology deadlock, where you're very much dependent on an on-premises environment, and you want to scale out, you want to expand into the into the domain of the cloud, but unfortunately you don't understand where you want to start from and how do you actually go about that. So you can always get in touch with us by just sending us an email with your query at info@royalcyber.com. Tell us about your problem and use cases, and experts from our team can actually connect with you, understand your challenges, and then we can do a free assessment for you, let you know what the situation looks like and how we can actually help you solve them. So again, thank you so much for being a part of the webinar. It was really great talking about all of the different services, the use cases, and finally the case study as well. I was really excited to share all of these insights with you. I'm really looking forward to hearing some great questions from you. And after even after the questions, if you guys again want to reach out to me, sumaya.baloch at royalserver.com, or you can search me on LinkedIn as well. And let's talk. So moving on to Q&A. Thank you so much.